Hello friends, welcome to Edupedia Word videos. In this video, we'll be learning basic proportionality theorem along with its proof. This theorem is also known as BPT theorem and Thales theorem with some modification in the statement. So the formal statement of this theorem says, if a line is drawn parallel to one side of a triangle to intersect the other two sides at distinct points, the other two sides are divided in the same ratio. That is, if a line is drawn parallel to one side of a triangle, say a line L is drawn parallel to QR, then according to this theorem, the other two sides are divided in the same ratio if the parallel line intersects the other two sides at distinct points. Now the other two sides are PQ and PR, and the PQ line is divided into PL and LQ, and PR is divided into PM and MR. So according to this theorem, their ratio will be same. That is, the two sides PQ and PR are divided in the same ratio. So let us have a brief discussion of proof of this theorem. Before proof, let us discuss a theorem which we'll be using here to prove BPT. The theorem says, if we have two parallel lines and if we have taken a base on one of these parallel lines and have drawn some triangles between these parallels, let these triangles be APB, AQB, AMB and ANB. Then the theorem says that the triangles on the same base and between the same parallel lines are having same area. So here area of triangle APB will be equal to area of triangle AQB and so on. Also, we need some information regarding the calculation of area in terms of perpendicular and base. So the second point that we needed is if we have certain triangles, let this be an acute triangle, let this be a right triangle, and let this be an obtuse triangle, then to find the area of such triangles, first of all, for the right triangle, it will be half into base, which is AB, into height, which is AC. Here also the area will be half into base into height. Now if we name this triangle as PQR, no doubt the base is QR, but for height we need to draw a perpendicular from P on this base. Let it be PD. So here the area will be half into QR into height. Friends, height is always the perpendicular drawn from the opposite vertex to the base. What about this obtuse triangle? In this case, it will again be half into base into height. Base here is no doubt TU, but what about height? As I have told you that height is the perpendicular drawn from the opposite vertex. let this be perpendicular to this base. So for here we need to extend this base to a point, say x. Now the perpendicular is sx, so it will be half into tu into sx. Hence area for a given triangle can always be written in form of half into base into height by proper construction. This will be using for obtuse triangle in the given question, that is the perpendicular can be outside the triangle also if it is an obtuse triangle. So using these 2 points, let us move towards the proof of this theorem. Friends, we are given this condition, that is L is parallel to QR, and we need to prove that if L is parallel to QR, then yes, these 2 sides are divided in the same ratio. So for proof we need some construction to use these formulas. First of all, we need to draw LF perpendicular to this base PM. Similarly, draw another perpendicular as ME perpendicular to PL. Further, some additional construction needed is join Q with M, and lastly we need to join R with L. Now Q with M can be joined as, and R with L or L with R is joined as this. Now friends, we have PL and LQ in the triangle PLM and LQM respectively. So utilizing this area concept, area of triangle PLM, because we need PL, so let us take base as PL into height. Now friends, it is somewhat like an acute triangle, so the perpendicular used will be EM. Similarly, to introduce LQ, let us have the area of triangle LQM. So it will be half into base, let the base be QL or LQ into perpendicular. This triangle assumes to be a shape of an obtuse triangle, so perpendicular for this triangle LQM will be EM, because EM is the perpendicular on extended side of QL, that is QP. So again the perpendicular will be EM. We have proved here that perpendicular can be outside the triangle also. So if we take the ratio of these 2 equations, that is dividing both the equations, we will get half get cancelled by half and EM by EM, and we will get the remaining term as PL over LQ. Similarly, now we need PM and MR, so we can take the triangle PLM again to have PM and its area as area of triangle PML, which will be equal to half. Friends, in the previous part we have used the base as PL because we were to introduce PL. Now we have to introduce PM. So we will be using the base PM. So half into base into height. If we take base as PM, then the height will automatically become LF over. Now to introduce MR, let us use the triangle LMR. So area of triangle LMR is equal to half into the base MR, and similarly it is also an obtuse triangle, so the perpendicular will be outside the extended base, hence it will become LF. Now if we take the ratio of these two equations, we will get the ratio of their areas as half gets cancelled by half and LF by LF, and the ratio becomes PM over MR. Now friends, using this concept, we have two parallel lines and two triangles LQM and LRM on the same base LM and between the same parallel lines. Thus we can say that area of triangle LQM is equal to the area of triangle LRM. That is, area triangle LQM is equal to area triangle LRM. Let this be equation number 4. So we can substitute this equation 4 over here. Let this be equation number 3. We will get area of triangle PML. Friends, PML or PLM is the same triangle, so we can write PML as PLM also. Now friends, LMR or LRM are one and the same triangle, so we can say that here LMR is rearranged as LRM. Now from equation 4 we can substitute the area of LQM in place of this term, so we get the redefined term as this. Let this be equation number 5, and let this be equation 6, where this is the left hand side and this is the right hand side. If we inspect the equation 6 and 5, their left hand side, we can easily say that their left hand side is same. That is, area of PLM is in numerator and area of LQM is in denominator. So on comparing equation 5th and 6th, left hand side is same, therefore right hand side will also be same. And if right hand side is same, we can say PL over LQ is equal to PM over MR. Hence the given to prove part has been proved. That is, if we were given the triangle, the parallel line L intersecting at L and M, then PL over LQ is equal to PM over MR. Now friends, there are also subparts from this theorem. Let this proved part be equation 7. Add numerical 1 to 7 on both sides. Then we will get PL over LQ plus 1 is equal to PM over MR plus 1. On taking LCM, we can say that PL over LQ plus LQ is equal to PM plus MR over MR. Thus PL plus LQ, which is the complete side PQ, over LQ. Now PM plus MR is the complete side PR over MR. This is the second part of this theorem, which says that the ratio of the divided part over the complete side is same in both the sides. Now if we move a little further, reciprocate 7, we will get LQ over PL is equal to MR over PM. Now again add 1 to both sides. We will get on LCM LQ plus PL over PL is equal to MR plus PM over PM, and PL plus LQ is PQ over PL, and PM plus MR is PR, and we have PM. So here we have included the upper part and the complete side in both the cases. In this part we have included the lower divided part and the complete side. Thus all in all we can say that the ratio of the divided part is equal for both the sides, as well as the ratio of any of the corresponding divided parts. That is, if we are taking this part, then we have to take this part. 2. The ratio of the complete side, PQ and PR, and the divided parts is also same. Here also the upper part and the complete side, their ratio is same. So friends, this was basic proportionality theorem and its proof. Thanks friends for watching this video.